Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this AWS Data Engineering Certification course, and in this particular video we are going to talk about RDS. So RDS stands for Relational Database Services. That is a service for the relational databases that are present on Amazon Cloud. So in the previous videos, we have already talked about multiple things like what is cloud. Then we understood about AWS cloud. Then we understood about the curriculum and the things that will be asked in the certification exam. And later on, we understood about what is region, what is availability zone, right? What is wavelength zone, and what is edge length. Edge zone, right? So we have already covered these concepts. So if you are someone who is not aware about these concepts, I would highly recommend you guys to watch those videos, and then you can continue watching this particular video. So with that said, let's get started with this video and let's get straight into the system. So this is the official documentation page of RDS. Okay. So here if you will see Amazon RDS and Aurora documentation. So Amazon Relational Database Service, that is in short called as Amazon RDS, is a web service that makes it easier to set up, operate and scale a relational database in the cloud. It provides cost efficient, resizable capacity for an industry standard relational database and manages common database administration tasks. Amazon Aurora is a fully managed relational database engine that's built for the cloud and compatible with MySQL and PostgreSQL. Amazon Aurora is a part of Amazon RDS itself. Okay. Now, if you want to get this particular documentation, what you will have to do is you can search for AWS docs. Okay. So here you will see welcome to documentation. You can click on this, right? And here you will be able to see multiple things, right? So here you can see Amazon Elastic Compute Cloud, which is we usually call as Amazon EC2, right? This is simple storage service, that is S3. Then we have DynamoDB. Then we have relational databases service, that is RDS. Then AWS Lambda is there. Amazon VPC is there. Amazon SageMaker, right? GenAI service and Kiro, right? If you want to choose and if you want to know or if you want to get the documentation of any other service that are not listed here, you can just scroll down, right? And here either category wise you can choose, or here you can choose anything. Let's suppose if I want to know about document DB. Okay. So here I can search for document and I can just click on this link. So here you can see the developer guide is there and Amazon document DB section for AWS CLI reference is also there. If you want to go ahead with CLI and if you want to basically interact with the document DB using the CLI command line interface, then you can go ahead with this documentation. Else, if you want to interact with UI or maybe some kind of SDK, then you can go ahead with the developer guide, right? And yeah, here you will be able to find all the developer things. Here you will be all the documentation part of all the services, right? Here also you can just click on any of the services. Let's suppose if you want to learn about any container service, so choosing AWS, choosing an AWS container service, right? Like how the decision guide and everything for which particular use case, what kind of container service will you choose, and all those things you can better understand and get to know here in this documentation. Then app to container, okay, Amazon Container Registry ECR. So this is also required for our certification. Then Amazon ECS, right? Amazon EKS, okay, and Red Hat OpenShift service on AWS. So these three services, that is ECR, ECS, and EKS, is also a part of this particular certification, our curriculum also. Similarly, if I talk about the database, so you can see there are 12 database services that are available on AWS cloud, right? So choosing a database service, right? So choose the right AWS database service. So if you want to know how you can choose which service, so you can just click on this link and you will be you will be better explained by the AWS people themselves that in what scenario, what use case, what kind of decision you can make. Then we have Amazon Aurora DSQL, that is distributed SQL database. Okay. Then Amazon Document DB, which is compatible with MongoDB. Then we have Amazon DynamoDB. Then we have Amazon Elasticache, that is in-memory caching service. Then Amazon Keyspace, which is equivalent to Cassandra, so managed Cassandra compatible database. Then we have Amazon MemoryDB, which is Redis compatible, durable, and in-memory database service. Then Amazon Neptune, so fully managed graph database service. Then we have Oracle database, so Access Oracle extra data infrastructure managed by OCI inside AWS data centers. Then Amazon Relational Database Service, that is RDS, so how we can set up, how we can operate and scale a relational database in cloud. And then we have Amazon Time Stream, so fully managed time series database we are having. Similarly, any kind of information or any kind of basically category wise if you want to choose, so you can choose here. So total there are 332 products or 332 services that are available on the AWS cloud as of today. Right? Then talking about the developer resources, means if we want to connect to the services using some kind of code, okay, maybe some kind of script, and we want to basically automate the things. In that particular case, we can take help of these SDKs and toolkits. So we have AWS CDK. We can connect using C++. We can use Golang. We can use Java, JavaScript, Kotlin, .NET, PHP, Python, Ruby, Rust, Swift. We can also connect using SAP. Then Amazon Corato. What is this? Corato, right? Amazon Corato. Azure DevOps also. Then here comes our IDEs, that is JetBrains, PowerShell, Amazon Q Developer, Visual Studio, and Visual Studio Code. Then we have some examples and all those things ready for us in the documentation. We also have nowadays, right? MCP servers are, you can say, MCP servers are nowadays used too much. So we also have our AWS documentation MCP server also. So if you guys want to go ahead with the MCP server, else I would currently not recommend you guys to go ahead with the MCP server, right? Because it can be useful when we are dealing with a large number of services at the very same time, right? Then this MCP server can come into picture and can be helpful for us. But currently we will be understanding about the services in a sequential manner. In a one by one phase, we will be understanding about the services. So currently I don't think that this some kind of this MCP servers and all these stuffs are anyhow required. Okay. So I hope you have understood that where can we find the documentations of all the services that we are having. Similarly, I have opened the documentation of our RDS and Aurora. So here we have the Amazon RDS user guide. Then we have Amazon Aurora user guide. Then Amazon Aurora DSQL user guide, which is the distributed version of SQL, and Amazon RDS getting started guide. Okay? So what I can do is I can just click on this RDS user guide and I will go ahead with the PDF part. I can also go ahead with the HTML thing. So if you are going ahead with HTML, so you will have something like this. Okay. And if you are going ahead with the PDF part, so for PDF, you will be having the very same information, right? It's not that we will have some different things, but it's just that it will be in a form of a PDF. So let me make it 175. Okay. So here you will be seeing each and everything in a form of PDF. So let me scroll down. Okay, so you can see here the very same things are given in the form of a PDF. So I just want to show you guys the starting of it. Yeah. So you can see what is Amazon RDS, right? And here also if you see, so the very first thing will be Amazon RDS itself. advantages, then comparison, right? So advantages, then comparison, then we will have this diagram, right? And here we have this same diagram, right? So if you want to go ahead with PDF, or maybe what benefit is you can download this PDF, right? If you are on, like if you are traveling somewhere, if you are going to office and everything, so you can just download this PDF, right? You can keep it safe with you, and moving forward, right? If you are traveling and something, so you can just open this PDF and read about it, right? So this PDF can be helpful in some ways. Otherwise, this documentation also is present, just like the normal documentations we usually have. Okay. Okay, so let's go ahead with this normal documentation itself. Can I make it in a white mode, because readability is not good for the recording purpose. So can I make it light mode anyhow? There is no option present for light mode. We have focus mode for sure. Not the thing. Yeah, I guess there is no option present for light mode. I hope the text is visible fine. Let me zoom in a bit more. Okay. Yeah, now I guess the text is better visible. Cool. Alright guys, so let's start with RDS, and what I will be doing is, let me open my AWS console also, so that moving forward, if I have to show you guys anything on the fly, means I have to show you guys how to create and how to implement. So what we will be doing and how we will be following is, we will start reading the documentation, we will understand the concepts, and then we will try to follow along with the documentation. If documentation asks us to do something in a practical way, that let's suppose this is how you can launch an instance, this is how you can choose your instance, and so on. So we will be doing the same thing on the console also. We will not just read it, we will do it practically too. Okay, so let's get started. So Amazon RDS is a web service that makes it easier to set up, operate, and scale a relational database in the AWS cloud. Okay, so I hope this particular line is very, very clear, right? That this RDS is a service that is hosted on some kind of cloud. It is hosted on some kind of remote server, right, at some specific location of the world. Or I would say, if I talk about now, so it is hosted in some kind of region of AWS, right, which we will be selecting using our console, right? So currently, because I am not the owner, right, so I will be able to choose some specific locations only, right? But these are the locations which I can choose from. Okay, so it is hosted on some kind of region, if I would say, and it makes it easier to set up, okay, operate, and scale a relational database in the AWS cloud. It provides cost efficient, resizable capacity for an industry standard relational database, and manages common database administration tasks. Okay, so it will be, first of all, cost efficient, because obviously if we have to set up our own things, right, if I have to set up my on-prem database, so for sure, firstly, I will have to require some kind of compute for that. I will require some kind of hardwares for that. Then I will need a space. I will need the networking capability. Then I will need the power. I will need the cooling thing, right? So all these things will be required before even dumping the first row of the data into my database, right? So if I'm going with the on-prem, so obviously it becomes very costly for me. But here I just have to do a few clicks and the instance, or I would say my database, will be launched in the cloud. Then we have a resizable capacity. Means, let's suppose today my organization is not that big, so I can spin up a small instance of the database. Moving forward, as my organization grows, as my you can say data user base grows, right? In that particular case, what I can do is I can start spinning up a larger instance of the database, right? So I will not have to pay, or I will not have to basically create an infrastructure in such a way that I can cater to the traffic that I am predicting will be after 3 years. I can gradually move to that particular traffic along with the user base that I am having at that particular period of time. Okay, so it's having a resizable capacity for an industry standard relational database, and it manages common database administration tasks. Okay. Now note, this guide covers Amazon RDS database engine other than Amazon Aurora. So for more information about Amazon Aurora, you have to click on this particular link, or you have to view this particular user guide. Okay. So here we will only be covering Amazon RDS. We will not be covering Amazon Aurora database. Okay. For Amazon Aurora, which is again a relational database itself, but it's having some different properties as compared to RDS. Okay. So obviously moving forward, we will also be covering Aurora DB also. Now, if you are new to AWS products and services, begin learning with more of the following services. Okay, so for overview of all products, you can go ahead with what is this? What is cloud computing? Then Amazon Web Service provides a number of database services. To learn more about the variety of database options and all these things, you can click on this, choosing AWS database service and running databases on AWS. You can go on to this link. Okay, then advantages of Amazon RDS. So Amazon RDS is a managed database service. So what does managed database service means? That RDS will be hosted, will be maintained, any kind of bug fix, any kind of update, right? Even the data that is present on my RDS, so that data should be stored in a secure environment. All these you can say all these responsibilities belongs to AWS people themselves. Okay, it's not our responsibility to do any kind of bug fix. It's not our responsibility to keep that particular database at a high availability, right? It's not our responsibility to basically spin up or maybe to create the whole infrastructure from the scratch, right? Each and everything will be done by the AWS people themselves. So it is, for that reason, it's called a managed database service. It's responsible for most of the management task by eliminating tedious manual processes. Amazon RDS frees you to focus on your application and your users. Okay, so the tedious manual processes, as I already told you that, right? So if you are having a raw server, right? If you are having a blank server, so first of all, I will have to install that particular RDBMS onto the server, right? Then I will have to do the administrative tasks related to it, right? Then moving forward, it's my responsibility to do the updates of, let's suppose the version of the database has been changed, right? Or maybe the support of that particular version that we are using is now being stopped. So I will have to update that particular database, right? Moving forward, if there is any kind of bug, so it will be my responsibility to fix that particular bug. I will have to maintain that particular server by myself, right? So not only I am involved on the product that I am building, I will also have to be involved in all these things. So Amazon frees us, or you can say Amazon RDS services frees us from all these manual and tedious tasks, and we can only focus on our applications and our business in that particular case. Okay, now Amazon RDS provides the following principal advantages over database deployment that are not fully managed. Okay, so you can use database engines that you are already familiar with, that is IBM DB2, MariaDB, Microsoft SQL Server, MySQL, Oracle Database, and PostgreSQL. Then Amazon RDS manages backups, okay, software patching, automatic failure detection, and recovery, right? So all these responsibilities now belongs to AWS, doing the backup of my data, right? Let's suppose if I'm having an on-prem database, right? If that particular database goes down, I lose my data, I lose my whole data, right? But here what they will do is they will automatically keep a backup of your data. So let's suppose if due to any reason any of the availability goes down in which you are working, they will be connecting you to the other availability zone. Okay, then software patching, we have already talked about it. Then automatic failure detection. Now let's suppose for any reason, right? For any reason there is some kind of failure, right? So if I am having an on-prem thing, in that particular case, all these failure detection, right, recovery management, and all those things will be our job to implement everything, right? Right from the scratch. But here, even the failure detection will be the job of AWS. Then recovery will also be the job of AWS people themselves. Now you can turn on automated backups or manually create your own backup snapshot. You can use these backups to restore a database. The Amazon RDS restore process works reliably and efficiently. Okay. So either I can turn on the automated backup. So now it will be everything like every backup and everything will be automated, right? And again, the responsibility of AWS themselves. Or we can also create our own manual backups, right? Let's suppose if I'm aware about the fact that I only receive the data on a weekly basis, right? So now it's not mandatory to do the backup on maybe after every hour or on a daily basis. So what I will do is I will create a snapshot of my database. Snapshot means you can compare it with kind of a screenshot itself of your phone, right? So what does a screenshot do? Whatever is visible on your screen, it creates a copy of it, right? That's exactly what a screenshot is. Similar is a snapshot of the database. Means if you are having a database, it will create a copy of that particular database. Okay. Now snapshotting means, let's suppose if I show you, okay. So you are having this database and there is some data that is residing on this particular database. So snapshotting just means I create a replica of this particular database. So I can create a replica of this database, and here I have created basically the snapshot of database, whatever this database is. Let's suppose this is a user's database. Okay, user database. So I have created a snapshot of user DB. Okay, so this is what basically snapshotting means. Okay, so now you can get a high availability with a primary database instance and a synchronous secondary database instance that you can fail over to when problems occur. You can use you can also use read replicas to increase read scaling. Okay, now what does this particular thing means, or what does this line means? Okay, let's understand. So now we have created what we are having a user, right? And we are having the snapshot of the database. So let me do it here. Okay, and let me create the replica something like this. Right now I am having some users. I am doing what? I am redirecting the traffic to this particular user, to this particular database. Okay, so let me do one thing. Okay. Here it is, user database. Okay, now I'm redirecting these users to and I'm redirecting, so I'm having this particular database, right? And I am redirecting the traffic to this particular database, right? And for some reason, right, let's suppose this is in US East 1 region. Okay, and this particular snapshot I'm doing what? Let's suppose this is I have created in the Europe region. Right now the traffic that I am serving is from this US East 1 region, right? Now for some reason this database goes down. Okay, now this database is down. Okay, so now because I have already created a snapshot of this particular database, right, and I have this replica already of this database, so I will do what? I will start redirecting as soon as I get the information that okay, this database or this region has basically failed. So I will start redirecting my traffic to this particular database in this way. Okay, so something like this, the traffic will get redirected to this database. Now user will not get to know, okay, maybe there is some milliseconds of latency that will increase, because let's suppose these users were from the US regions, right, and these US regions were interacting with this particular database. Now they are interacting with a database that is now in the Europe region, right? So maybe a very minor latency, that is of few milliseconds or a few microsecond, may get increased, but the users will not get to know that okay, there has been some kind of issue, or there is some kind of error that has happened internally of the system. They will keep on using the system in the same way that they were using. Okay, now what also we can do is, right, let's suppose we are having a condition where we have a lot of read request but we don't have that much write request. Means, let's say this is my database, right? This is my database, and again let me have these users. Okay, these are my users. So these users are reading the data from my database very, very frequently. Okay, so the read request from my database is very, very high. Something like this. And the write request is not that much. So let's suppose this user has written to the database, right? And he has also done a read from the database, something like this. Okay, so you can see here most of the traffic is read only. Okay, so in this particular case, what I can also do is maybe this one. So currently we are like I have shown only 3 users. When millions of users start doing the same thing, right? Let's suppose we are having an Instagram, right? So Instagram users are scrolling reels more as compared to they are posting the reel, right? If you understand it in this way, so Instagram users are scrolling the reels more, right? They are spending more time reading, right? Or maybe fetching the data from the database more as compared to they are inserting the data into the database. Means they are posting some reels or posting some post on the Instagram, right? So in that case, what we usually do is we create some kind of read replicas. Okay, so we don't write into these databases. What we usually do is, let's suppose if I have to do any kind of write operation. Okay, so this is the main database. Let's say this is my main DB. Okay, and now if I have to do any kind of write request, so what I do is I will write to the main database. Okay, and if there is any kind of read that I have to do, so these are what? Read replica of main DB. Okay, similarly this is also a read replica of main DB, right? So I have basically created a replica. Okay, replica means again the snapshot or the copy paste of that particular database itself, right? So whatever data is there, okay, whatever data is there in this database, same data will be present in these databases also. Now if further they have to do any kind of read request, so they will be doing the read from this particular database, right? Or the read request of this user may also get served from this database itself, something like this. Okay, and here if I want to write anything, right, so let's suppose this user now wants to write, so write request will only be done to the main database, something like this. Okay, so I hope now this is clear. So let me do one thing, let me change the color also. So let's suppose this is the read request, sorry, this is the write request, and this is the write request. Okay, and rest of the things are read request, right? So I have make this thing opposite. It should be something like this, right? So these things are read request. So all the read request will be processed from where? It will be processed from the read replicas, something like this. Okay, so these red ones are the read request and the green ones are write request. So write request are getting stored directly dumped into the main database, right? And the read request is now being processed from the replica database. So now this helps us in maintaining the high availability of our main database. Okay, it's because we are already aware about the fact that our RDBMS runs on a concept called as acid properties, right? So if I'm having a very high read request, right, so what it will do is, unless it has not processed all the read request, it will not do the write request, right? Let's suppose we are having our queue in this way, right? Let's suppose I'm having read 1, I'm having read 2, I am having read 3, I'm having read 4, then I'm having write request 1, then I'm having read 5, right, read 6, okay, read 7, read 8, right, read 9, then maybe write 2, something like this. So what it will do is, it will follow a sequential manner if you are using the same database, right? If you are only using this main database, then this write operation would had to wait unless these 4 read operations have not been done, then only this write operation will be. So after these read operations have been done, then only this write operation will be done. Then again these read operations will have to be done, then only this write operation will be done on the database, right? So the user who are trying to write the data into the database, they will have to wait, or they will they will see some kind of high latency. Okay, so to overcome these things, what we usually create if we are having a high read request is we create these read replicas. Okay, so I hope now the use of these read replicas, where did it go? Manually we create our on this, and yeah, this one. Okay, so you can get a high availability with the primary database instance and a synchronous secondary DB instance if you fail over the problem when problem occurs. So this is what we have discussed here, right? The failover part we have discussed. Now talking about the you can also use read replicas to increase read scaling, and this is what we have done here. Okay, it's not that this main database cannot serve reading, right? It can also serve the read request, but usually we try to redirect on the read replicas itself. Okay, now in addition to the security in your database package, you can control access by using AWS identity access management, that is IAM, to define users and permissions. You can also help protect your database by putting them in a virtual private cloud or VPC. Okay. Now comparison and responsibility with Amazon EC2 and on-prem deployments, right? So what we can do is, now let's suppose if I want to save some money, okay, because if we will be having a managed service, in that particular case, obviously I will have to pay some kind of premium, right? So if I want to save some money and I am using my mind, I'm doing what? I am launching an EC2 instance and I am deploying my database, or I am spinning up the database on the EC2 instance. So in that particular case, what all things will differ? Now we will do that particular comparison. So we recommend Amazon RDS as your default choice for most relational database deployments. The following alternative have the disadvantage of making you spend more time managing software and hardware. Now, if you are going ahead with the on-premises deployment, okay. So when you buy an on-prem server, you get CPU. You get CPU, memory, storage, and input-output operations all bundled together. You assume full responsibility of the server, operating system, and database software. Okay. So if you are building an on-premises cloud, or maybe if you are doing an on-prem deployment, in that particular case, we will only have the machine. So this thing means if I cut it into one line or one word, I would say, we will only get a simple raw machine, okay, which will have what? Which will have some kind of compute power in the form of CPU. It will have some memory, right? It will have some storage and input output operations, IOPS, right? Means I can basically do the input and I can do the read and write request, right? It will be our responsibility to manage the server, to manage the operating system on the server, as well as the database software, right? Now, if we are going ahead with the EC2 instance, so Amazon Elastic Compute Cloud, that is Amazon EC2, provides scalable computing capability in the AWS cloud. Unlike in an on-prem server, CPU, memory, storage, IOPS are separated so that you can scale them independently. AWS manages the hardware layers, which eliminates some of the burden of managing an on-prem database server. Okay. Now the disadvantage to running the database on Amazon EC2 is that you are more prone to user errors. For example, when you update the operating system or a database software manually, you might accidentally cause application downtime. You might spend hours checking every change to identify and fix an issue. Okay. Now again, let's suppose, so it will be now our responsibility if you are spinning up the EC2 instance. So the operating system will be our responsibility, right? If you are going ahead with the Linux system, if you want to go ahead with the Linux system or something like that, right? Then again installing the RDBMS software will be our responsibility, right? The Amazon people will not spin up an EC2 instance with the system already, or I would say the application already installed on that, right? It will be our responsibility to install those applications, RDBMS applications, right? Now let's suppose if I'm doing some kind of system upgrade, right? Or maybe operating system upgrade if I'm doing, right? So maybe the version of the database that I am using at that point of time may not be compatible with the version of the Linux that I am using. Okay. In that particular case, my database will go down. Okay. My database will go down and I will not be even able to process this particular thing if it is occurring for the very first time, that what exactly was the error, was the issue, and my system goes down, right? What I will try to do is I will try to check the logs, right? I will see that everything is fine. I will try to check the network, everything is fine. I will try to check what we call the RAM, right? The RAM uses, the input output operations uses, right? The disk space is there or not, everything will be fine. The issue will be what? The version compatibility, right? I will try to hit my head multiple times, then maybe I may get to figure out that, okay, it was the version compatibility issue. Okay. So that's what that's what one kind of issue that can happen if you are spinning up our database or if you are managing our database on the EC2 instance. Now the following table compares the management models for the on-prem database, Amazon EC2 and Amazon RDS. So if you're talking about application optimization, so if you're doing an on-prem management, so it's our responsibility, right? If you are going ahead with EC2 management, it's again our responsibility. And even in RDS, right? Even for the RDS also, it's our responsibility to optimize the things, right? No one is going to optimize the queries the data storage, right, the data modeling part for us, right? It's obviously and always our responsibility. Now talking about the scaling. So on-prem, if I talk about, so everything will be customer's responsibility, right? That is for sure. If I'm going ahead with on-prem, so everything will be customer's responsibility. Now, if I'm going ahead with EC2 management and if I'm going ahead with RDS management, so if the scaling, if I'm going ahead with EC2, so it will be my own responsibility. And if I'm going ahead with RDS, so now the responsibility belongs to AWS, that they will be basically scaling up and scaling down my instances. High availability, again on-prem customer, EC2 will be customer's responsibility, RDS it will be AWS responsibility. Database backups, on-prem customer's responsibility, EC2 customer's responsibility, RDS Amazon responsibility. Database software patching, customer responsibility, and patching again is AWS responsibility. Database software install, customer, and AWS. Operating system patching, customer, AWS, right? Operating system installation, customer, AWS, right? Server maintenance, now it becomes customer, and AWS will maintain our EC2 also, because EC2 again is a server itself, right? And they are giving us a service, a managed server service in EC2 too, like EC2 also, right? So server management is a part of AWS and AWS. Hardware lifecycle will be, if I'm going ahead with on-prem, obviously it's my responsibility. For EC2 and RDS, it's AWS responsibility. Power, networking and cooling, it's customer responsibility. It's AWS responsibility for EC2 and RDS both. Okay. Now let's understand Amazon RDS shared responsibility model. Okay. So Amazon RDS is responsible for hosting the software components and infrastructure of database instance and database clusters. Okay. So everything, if I'm using Amazon RDS service, right, in that particular case, it will be Amazon's responsibility to host the components, the software components and the infrastructure of, if I'm using one single instance, or even if I'm using the whole cluster of the database. You are responsible for query tuning, which is the process of adjusting SQL queries to improve the performance, right? So only the application optimization part belongs to the customer, right? Which is again the query tuning part, right? So if I'm using any big instance, right, but if I'm not writing the correct tuned query, correct SQL query, right, in that case I may get some kind of performance bottleneck, right? So doing and tuning the performance query is our responsibility as a customer, right? Query performance is highly dependent on database design, data size, data distribution, right, application workload and query patterns, which can vary greatly. Monitoring and tuning are a highly individualized process that you own for your RDS database. Okay. You can use Amazon RDS Performance Insight and other tools to identify the problematic queries. Okay. So Amazon also provides us the performance insights tools and other tools like AWS CloudWatch, right, using which we can connect to the RDS instance and we can get to know that which query is not a optimized query, and then we can try to figure out that how I can optimize that query. That is also a service that is available on AWS, but optimizing it is our responsibility, right? Keeping the database design good, right? Deciding the data size, deciding the data distribution, the application workload and the query pattern is our responsibility, right? And based on these things only, or based on these factors, I would say the query performance can vary. Okay. So I hope this shared responsibility model is also clear, right? That whatever query I am writing, right, or maybe the optimization part on the code level optimization part, or the SQL level optimization part, the database design optimization and the data distribution optimization is our responsibility. Rest of all the things, right from installing the software, to managing the operating system, to keeping the availability, the scalability, managing the power backups, the database backups, right? And even identifying the problematic query and troubleshoot, like giving you some kind of you can say a notification in case of some kind of issue, and all those things belongs to AWS. So you can understand how much manual work we are cutting down if you are using these managed services that are provided to us, right? So if you are a startup, right, if you are an early age startup, so we now don't have to focus on all these things. I just have to worry about my application. I just have to worry about my marketing and all those stuffs. Okay. All right. So now let's understand about Amazon RDS DB instances. So a DB instance is an isolated database environment in the AWS cloud. The basic building block of an Amazon RDS is the database instance. Your DB instance can contain one or more user created databases. So the following diagram shows a virtual private cloud that contains two availability zones, with each availability zone containing two DB instances. Okay. So now here the outer layer, right? If I talk about this one, this box is whole the whole AWS cloud infrastructure, or maybe you can say this is one of the region. So this can be, let's suppose, US East 1 region, right? This can be US East 1 region. Inside this US East 1 region, we are basically using two availability zones that are available. Cool. Now inside these two availability zones, we have spin up, or I would say first of all, we have spin up a VPC, that is virtual private cloud, right? So virtual private cloud again is a service, right, which will protect from any kind of unauthenticated user entering my environment, you can say, right? This is my whole database cluster, or you can say database environment. So any kind of unauthenticated user, unassigned user will not be able to bypass this VPC and will not be able to basically authenticate or access my data that are residing in the database. Okay. Now inside this VPC, right, we have launched two instances of Oracle DB, right? So two instances of Oracle DB in availability zone 1, right? And one PostgreSQL instance and one MySQL instance in availability zone 2. Okay. So currently I am having total 4 databases, okay, spread across 2 availability zones, right? Out of which 2 is Oracle instance, right? 1 is Postgres and 1 is MySQL DB, right? So this is the current infrastructure of my this is my current infrastructure, and this whole belongs to, you can say, one region. And obviously one VPC is also there, one private cloud service we have also launched. Okay. Let's move forward. So even though you are not very well aware about what is VPC, right, and why it is used, so just think of it as a you can say authentication mechanism, right? I will have to authenticate and I will have to prove to this VPC that, okay, I have the authorization to access the data that is present inside these databases, then only I will be able to access them. So you can see, you can say that this VPC is kind of a firewall, okay, or you can say a protector, right? Just understand in this way that it is a protector of the databases allowing any kind of disallowing any kind of unauthenticated access, right? So you can access your database instance by using same tools and applications that you use with a standalone database instance. You can create and modify a database instance by using the command line interface, by using the RDS API or AWS management console. Okay, so we have three ways using which we can interact to the resource, or you can say the RDS. First one is using AWS CLI. Second one using some kind of SDK, right? And SDK using the RDS API. Let's suppose if I'm using Python, so I will have to use Boto3 in that particular case, right? Or using the AWS management console, that is this whole CLI, whole UI, and using this UI, I can interact with my RDS service. Okay. Now let's understand about the RDS application architecture. For example, the following image shows a typical use of dynamic website that uses RDS database instance for a data storage. Okay. Now you can see here, right? So first of all, we are having Route 53, right? So which is basically a DNS resolution service, right? So DNS is what? Domain name server, right? So it will okay, let's not go into that depth. Okay, let's not go into that depth. Users will be there, right? These are users, right? We have a region, right? This is our region. This whole is our region, right? Inside this region, we have what? We have spinned up our VPC, that is our virtual private cloud, and inside this VPC only we will spin up our services. Okay, so inside this VPC we have first of all the internet gateway, we have our route table, okay, we have our elastic load balancing service, auto scaling groups, right? And then using this elastic load balancer, we are basically we have launched our same service, or you can say the same infra on two availability zones, right? So this is one availability zone, this is the second availability zone. Then we have the public subnet in both of the availability zones, and inside this subnet we are having our application server that is running. So this application server may be using an EC2 instance, it can be an EMR instance, it can be a Lambda function, or anything, depends on what kind of application we are having, right? And using this elastic load balancer, right, the traffic is getting distributed between these two application servers. And just notice one thing here, that the application server is in public subnet, right? Means the application will be accessible to the public, whoever is requesting on my particular route or my particular IP address basically that has been provided, right? Now this Amazon RDS DB instance, okay, Amazon RDS DB instance is in a private subnet, means I will not be able to, or I will, this particular instance or this particular subnet is not publicly available, means anyone cannot just enter this RDS IP address if by any chance he is having, and he can access it. No, he will have to first of all authenticate, and then only he will be able to access, even though he is having the IP address of the RDS instance with him, right? And here you can see the main RDS instance or the main DB instance is in this availability zone. Maybe you can say this is availability zone 1 and this is availability zone 2, right? So in availability zone, the main RDS instance is present, and the replication of this RDS instance is created on the availability zone 2 to cater the fault tolerance and create a kind of backup, right? And you can see here Amazon RDS standby instance will be there. So if by any chance this particular RDS goes down, maybe due to, let's suppose, network issue, power issue, right, any kind of natural disaster or something, the traffic from this particular instance, right, the traffic that was going earlier to this instance will be diverted to this particular instance, something like this, right, which we have already talked about earlier in the in this video itself, right? Now let's understand what exactly these components are, right? So the primary components of the preceding architecture are as follows. So the elastic load balancing, AWS routes user traffic through a elastic load balancing. A load balancer distributes workloads across multiple compute resources such as virtual servers. In this sample use case, the elastic load balancer forwards client requests to the application server. Okay. Now there is application server. So the application server interacts with the RDS database instances. An application server in AWS is typically hosted on EC2 instances, which we have already talked about, which provide a scalable computing capacity. The application server resides in the public subnet with different availability zones within the same virtual private cloud, right? Again, we have the same VPC, right? And inside this VPC, we have utilized multiple availability zones, or here in this case, two availability zones, right? And this application server is interacting with our RDS instance for maybe fetching the data, right? Or maybe right for reading the data, or maybe for writing the data. Okay. Now this RDS DB instances. So the EC2 application server interacts with the RDS DB instance. The DB instance resides in the private subnet within different availability zones within the same VPC. Because the subnet are private, no request from internet are permitted. Okay. Here you can see using the internet gateway, it is accessible through the internet, right? But this is because of it is in private subnet, it will not be publicly accessible on the internet, even though we are having the IP addresses and all, as I have already told you. So the primary DB instance replicates to another DB instance called the read replica. Both DB instances are in private subnet within the VPC, which means that internet users cannot access them directly, right? Now talking about the DB engines. So a DB engine is a specific relational database software that runs on your DB instance. Amazon RDS supports the following database engines. So RDS supports Amazon DB2, it supports MariaDB, it supports Microsoft SQL Server, it supports MySQL, Oracle DB, and PostgreSQL. Okay, so if you want to read about any one of them in more detail, you can just go on to that link. So currently I will not be going on to some specific engine. Let's first of all understand about the RDS itself. Now each DB engine has its own supported features. Each version of the database engine can include specific features. Support for Amazon RDS feature varies across AWS regions and specific versions of each database engine. Okay. This means that maybe there can be a feature that is present in Microsoft SQL Server that may not be present in MySQL. Similarly, Postgres is having some additional features as compared to Oracle DB and MySQL, right? Like it can store some kind of geographical area, right? Nowadays, the latest version of Postgres is also able to store some kind of document like data and all, right? So Postgres has started to give those supports, right? So it may be available in Postgres engine, but it may those functionalities and those features may not be available in all the other database engines, right? So we have to, according to our use case, we will have to check, right? And then only we will be able to choose the best and the appropriate database engine that we should be using. So to check the feature support in different engine versions and regions, we can go on to this particular link and check about it. So let's open it and just quickly see, right, what is there. Okay, so now you can see. So blue-green deployment, right? So what is blue-green deployment? Let's not get too much into it. So just think about in this way, that if we are doing multiple deployments, right, or maybe frequent deployments, in that case we go ahead with blue-green deployment, right? If I have to maybe push some kind of features on a daily basis, right, or I'm getting multiple features pushed on our system on a daily basis, in that case we go ahead with blue-green deployment. Just understand about this much, right, currently. So for RDS DB2, it's not available. For MariaDB, it's available. SQL, it's available. Oracle, it's available. Postgres, Oracle, it's not available. Postgres is available, and SQL Server is not available, right? Similarly, cross region automated backups, everything is for every engine it's available. Database activity streams, so DB2 not available, MariaDB not available, MySQL not available, Oracle it's available, PostgreSQL not available, and SQL Server it's available. So you can check, right, according to your use case, right? Let's suppose you want Kerberos authentication, right? So you cannot choose MariaDB in that particular case, so it's already eliminated, right? You have to choose from other, and like that, according to the requirement and everything, you can get to know and get to choose about what kind of support is there for what engine and not. Okay, and this is for the very same reason, right? I say, or I focus on like going through the documentation, because all these things you will not be able to get in any video, right, or maybe any notes that you will be following apart from the official documentation itself, because no one writes in this much depth, right? Unless you are following the official documentation, no one is bothered about these minute things that are there, right? Now additionally, each database engine has a set of parameters in a database parameter group that controls the behavior of the database that it manages. For example, and more information you can see onto this link. Now the DB instance classes. Okay, so when we will check about what instances are there inside for launching our database, you will see different kind of classes like DBM, DBZ, DBX, DBC, and DBT, something like this, DB.T, DB.C, and like this. So what does that particular thing means? We will understand it here. Okay. So a DB instance class determines the computation and the memory capacity of the database instance. A DB instance class consists of both the DB instance class type and the size. The Amazon RDS supports the following instance class types, where the asterisk represents the generation, optional attributes, and size. Okay. So if it is a general purpose database instance, it will be db.m dot something something. It will be there something like this. You can see, right? db.m 7G is the generation. Okay. And 2XL is the, sorry guys. Okay. 2XL is the size. Okay. Similarly, if I talk about the memory optimized instance, so it can be db.z, db.x, and db.r. Now if I want compute optimized, in that particular case it should be of the series db dot, or I can say of the class db.c. If I want burstable performance, like a high performance instance, in that particular case it should be of the family db.t. Okay, so each instance class offers different compute, memory, and storage capabilities. For example, db.m7g is a 7th generation general purpose database instance. Okay, class type powered by the AWS Graviton 3 processors. Okay, so these general instances, it will be powered by which this Graviton 3 processors. When you create a DB instance, you specify a DB instance class such as db.m7g 2XL, where 2XL is the size. For more information about hardware specifications of different instance classes, we can go on to this particular link. But I don't think currently it's very, very important for us to go on to that particular level, right? Let's not waste that time. You can select the DB instance class that best meets your requirement. If your requirement changes over time, you can change the DB instance class. For example, you might scale up from a DBM7G 2XL instance to DBM7G 4XL. For more information, you can go on to this particular link and know more about the DB instance classes. Let's understand about the DB instance classes. I hope we will get the DB instance class. This. Okay, you can see here. right? So if you are going ahead with a general purpose instance class powered by AWS Graviton 4 processor, right? So you can see if you are going ahead with DB M8, so currently, even though in the documentation it's currently M7 itself, but now we have the 8th generation instance available for us, right? So M8G, right? 48XL. So 48XL will be what? It will have 192 virtual CPUs, right? You can also call it as core. 768 GB of memory, 768 GB of RAM. It's EBS optimized only. Means EBS stands for elastic. Okay, elastic beanstalk, I guess. EBS AWS full form. Elastic block storage, right? EBS stands for elastic block storage. So EBS optimized only, right? Maximum EBS bandwidth is 40,000 MB per second, means 40 Gbps. Just understand. And network bandwidth is 50 Gbps. Okay, 50 Gbps. Now, if I am going ahead with this smaller instance, that is DBM8G large. Okay, so it will have 2 cores, right? It will have 8 GB of RAM. Okay, the maximum bandwidth will be up to 10,000 Mbps, that is 10 Gbps, and maximum EBS bandwidth will be 10 Gbps, and network bandwidth will be up to 12 Gbps. If I talk about the different other classes, right? Let's suppose instead of general purpose, okay, so this all is general purpose, I believe, right? So these are all of different generations, you can see, right? So this is a DB M5 generation. So the very first generation would have been this one, DB M3, right? So this was this, right? So you can only see it was having medium, large, XL, and 2XL, right? Then in generation 4, it became up to 16XL, right? In generation 5, the largest instance was 24XL or extra large. Right, even the hardware specification and everything got changed, right? Everything got changed, everything got better with every generation, right? So here again it got better. Here you can see, right? We also had something called as M6 metal, where it was having 128 core CPU, right? This much processor cores, right? And then this much, and 512 GB of RAM and something like these, right? Then again, here you can see, right? Again here 32XL. Then at last, for the last version, we have what? We have 48XL, 48XL size that we are having, right? So every generation will have some kind of improvements associated with them. Now the DB instance storage. So the Amazon EBS provides durable block level storage volumes that you can attach to a running instance. DB instance storage comes with the following types. So the first storage is the general purpose storage, that is the normal SSD storage that we are having. So this cost efficient storage type is ideal for a broad range of workload running on medium sized DB instances. General purpose storage is best suited for development and testing environments. Okay. Then provisioned IOPS. So this storage type is designed to meet the needs of input-output intensive workload, particularly database workload that require low input-output latency and consistent input-output throughput. Provisioned IOPS storage is best suited for production environments, right? So if you are going ahead with just a kind of development and testing environment, right? In that particular case, we can go ahead with the general purpose storage, right? Because in this particular case, latency and all these things does not matter too much, right? Even though it matters for the testing purpose, we will have to at least get a basic, you can say a basic insight or a basic analysis that what is my IO latency is, right? But it does not matter, and we are very well aware about the fact when we will change our storage from general purpose SSD to provisioned input output of storage. In that particular case, it will automatically enhance, right? Now, if you are into the production environment, in that particular case, it's recommended. It's not mandatory. It's recommended that we should go ahead with the provisioned IOPS storage type. Then we have something called as magnetic. So magnetic was the previous thing, right? So AWS RDS supports magnetic storage for the backward compatibility. We recommend that you use general purpose SSD or provisioned SSD for any new storage needs, right? So magnetic storage was used very long time ago, right? But like RDS still supports it, but they themselves are saying that it's recommended that you use the general purpose or the provisioned input output of SSD. Okay. So the storage types differ in the performance characteristics and price. You can tailor your storage performance and cost to the requirement of your database. Each DB instance has minimum and maximum storage requirements depending on the storage type and database engine it supports. It's important to have sufficient storage so that your database have room to grow. Also, sufficient storage makes sure that the feature of the database engine have room to write content or log entries. For more information, you can see onto this particular link. Right? So now we have the DB instances in the Amazon Virtual Private Cloud, that is Amazon VPC. So you can run a DB instance in the VPC using Amazon VPC service, right? So first of all, you will have to launch the VPC, and then inside that VPC you will have to basically spin up your RDS instance. So when you use a VPC, you have a control over the virtual networking environment. You can choose your own IP address range, create subnets, and configure routing and access control list. Okay. So in VPC, I will be having the flexibility and the capability that I can choose the IP address range. Means, let's suppose my servers, and I am aware about the fact that the server that on which the application server, I can say the application server IP address range is between, let's say, xxx dot 1 dot something like that. So IP address is something like this, right? Let's suppose it's it may be 192, right, dot 53. Okay, it's something like 192, right, dot 53, okay, dot 48, right, dot 227, something like this. Okay, so maybe I have a range of IP address between 192 to, let's suppose, 194 dot 53, right, dot, let's suppose, 55, right, dot, let's say 337, something like this. Okay, so I can just set up this much range, right? I can set up my IP range that the IP addresses that fall between these range will only be allowed to access my RDS instance. Then create subnets, right? So as we are already aware about it, that we have a public subnet, right? So we have a public subnet and we have a private subnet. So public subnet is accessible to the internet. If any service is present in my public subnet in using internet, I can access it, right? But this private subnet is not accessible to internet. This connection will not be allowed, right, in the private subnet. So obviously I will be launching my RDS instance in the private subnet and using the application server or maybe the EC2 instances which I will be having. I will be communicating with my with my RDS instance. Configure routing, access control list, and all these things are also a part of VPC, that is Virtual Private Cloud. So moving forward, when we will talk about VPC and Virtual Private Cloud, we will be talking more about it. So the basic functionality of Amazon RDS is the same whether it's running in VPC or not. Okay. So if you are running in VPC or if you are running without VPC, RDS instance will work exactly the same. There will not be any kind of difference between the working of RDS instances. It's more of a security part, it's more of a governance and privacy part that we launch it into a VPC. Okay. Amazon RDS manages backups, software patching, automatic failure detection and recovery. There is no additional cost to run your database instance in a VPC. For more information on using Amazon VPC with RDS, we can go on to this particular link and we can get to know more about it. But currently, we will be launching it without any kind of VPC. Amazon RDS uses network time protocol NTP to synchronize the time on the database instances. Okay, so when we are dealing with the timestamp data, right? Let's suppose if I am creating such a way, right? If my table schema in this way that I have to store the user details and the login time, or you can say the sign up time, is I have written as timestamp. So that timestamp will be calculated using what? The timestamp will be calculated using the Amazon RDS time, and that particular time will be calculated using the network time protocol. Okay, so this network time protocol is basically you can say is equivalent to the UTC, right? It's universal time calculator, something like that. Again, I don't remember the full form. So UTC full form, if I talk about coordinated universal time. Okay, so UTC stands for coordinated universal time. So it's nearly equivalent to the UTC time itself. Now let's talk about AWS regions and availability zones. So Amazon Cloud computing resources are housed in highly available data center facilities in different areas of the world. For example, North America, Europe, or Asia. Each data center location is called as an AWS region. So we are already aware about this fact that what a region is. With Amazon RDS, you can create your DB instance in multiple regions, right? So Amazon gives us this flexibility or gives us this option that we can launch our RDS instance in multiple regions of the world. So the following scenario shows an RDS DB instance in one region that replicates asynchronously to a standby database in the different region. So if one region becomes unavailable for any reason, right, the instance in the other region is still available, right? So you can see here, right, that this main database instance is having both read and write access, and the clients can access this database. So maybe this particular is in the USA region, right? This can be in USA region, and this can be, let's suppose, in Europe region, right? This can be in Europe region. So the clients are working perfectly fine, right? This is our RDS instance, right? We are having our application running, and the clients are able to access do both read and write operations to my database. Cool. Now, as soon as due to any reason, right, this particular region goes down, right? Now this region is not working. So it will do what? The clients will automatically switch to the replica read region, right? So here the client will now only have the read only access, right? Let's suppose if I'm taking an example of again Instagram, right? If I'm taking an example of Instagram again, right? So in this particular scenario, I will be able to see everyone's post, right? I can see the post on my phone, right? As well as I can also post anything, any picture, any video that I want to upload on the Instagram. So I can do the uploading part also. I can do the uploading part also. Okay. Now, due to any circumstances, this particular USA region is now down, right? And I have to switch my read and write operation, or I would say my read operation, to the Europe region for the US clients. So these are USA clients itself. Okay. Obviously, I will not be launching an RDS instance for Europe clients in the USA, correct? Now, this read replica is of USA region, right? So this read replica is of USA region, even though if it is in the Europe region. Cool. Now, this user has been now switched to this particular RDS instance, right? And this is just a read replica, right? I can create an exact replica also, where I can do both read and write, right? Or I can just create a read replica. So that now in this case, what will happen is I will be able to view the post on my application or on my smartphone. The post will be accessible of everyone. I will be able to scroll through the reels and everything, but I will not be able to upload anything. Let's suppose I'm trying to upload any post, I'm trying to upload any reel. In that case, it will give me an issue. Okay, it will give me an issue. But you can think of the positives as well as the negatives both in this case, right? The positives is that, like, most of the users are you can say scrollers, right? If I talk about Instagram, right, so most of the users are consumers, I would say, right? They are just consuming the content. So content consumption will be there, right? This way traffic is always available, right? The traffic or the data is always coming from the database to my smartphone, but I cannot upload. So the consumers will not see any kind of difference, right? The only difference can be a microsecond of latency, right? So the consumers will be able to see. The producers, or you can say the creators, they will not be able to upload the data for some time till this region comes back, right? And now after, let's suppose 20 minutes, 30 minutes, 1 hour, whatever time period, right, this region is now again back. Okay, so again I will switch back to my previous architecture, right? I will be reading I will be reading from this particular database, as well as I will now be able to upload the content also. Okay, so this is how basically so this is a condition where I have encountered a fault, right? There is some kind of issue that has happened to the architecture or to my application, right? In that case also, I am at least able to cater most of the users of my application. And this is how basically we do our fault tolerance part. And if I'm not only creating this read replica, I am creating you can say a clone of it, or an exact replica. In that particular case, I will be able to do both read and write. So I will be able to serve 100% of my customers. So again, it depends on the use case, I would say, right? Again, if I talk about, let's say, Instagram, YouTube, applications like these, so they are having you can say millions of videos uploaded in every minute, right? So they cannot even afford for a 1 hour downtime even for the upload part of it, right? So I just gave an example of Instagram here, but now I'm talking about the real scenario, what Instagram is doing in reality. Okay, so they cannot even afford of 1 hour of downtime even for the upload part of it, right? So they will create an exact replica. They will create an exact replica of it, that if, let's suppose, this database is down, right, this exact replica will do both of the things. It will do the read operation also, and it will do the write operation also. Okay, so I hope you guys are now understanding the concepts better. Now comes the availability zone. So each AWS region contains multiple distinct locations called availability zones, or AZ. Each availability zone is engineered to be isolated from failure of the other availability zones. Each is engineered to provide inexpensive, low latency network connectivity to other availability zone in the same AWS region. By launching DB instances in separate availability zones, you can protect your application from failure of a single availability zone. For more information, you can go on to this particular link, right? So I believe most of you who follow the tech news, right, must have heard that US East 1 was down, right, of AWS. US East 1, I believe in December starting or maybe in November end, right, this particular thing happened, that US East 1 region was down. Okay, so when this region was down, all of the availability zones were down, right? So I believe there are 6 or 9 availability zones in US East 1, right? So all of the availability zones were down in that particular case, right? So I will have to rely on some kind of other region, some kind of Europe region, right? Some kind of Europe region to act as a backup for me. Now there can be a backup on the availability zone level also. So let's suppose this is availability zone 1, right, in US East 1. So this is US East 1. Okay, and this is my availability zone 2, and this is availability zone 1. So the power supply, right, let's suppose power is getting supplied, right, from company X, right. Let's suppose cooling is getting done by some company Y, right. Let's suppose company Z is providing the networking part of it. Okay, and something like this. So here what will happen is this availability zone 2, it will have company A to provide the power, right. It will have company B to provide the cooling facility. Okay, it will have company C to provide the networking service, something like this. Okay, I'm not exactly telling you, right, but something like this will happen because for any reason there is a power cut of company X, right, and this availability zone 1 goes down. The same issue should not happen with the availability zone 2, because here the power is the power supply is of company A. So this availability zone 2 will keep on running and it will be active, right. Maybe due to any kind of natural disaster, maybe cyclone, a flood, something like that has happened. In that particular case, this whole region can also go down, right. So it totally depends on what kind of uh, uh, you can say what kind of disaster, what severity of failure has happened. Okay, now multi availability zone deployment. So how we can do the multi availability zone deployment, let's understand about it. So you can run your DB instance in several availability zones, an option called as multi AZ deployment or multi availability zone deployment. You can choose this option. When you choose this option, Amazon automatically provisions and maintains one or more secondary standby database instance in a different availability zone. Your primary database instance is replicated across availability zones to each secondary database instance. Okay. Now in this case, right, you can see. Okay, let's first of all read whole thing, then we will understand about the image. So a multi availability zone deployment provides the following advantages. So providing data redundancy and failover support, right? Data redundancy means data replication, you can say, right? That my data is getting replicated multiple places. So even though if I lose the data from one instance, it will be available in the other instance, right? And failover support. So how failover support is there? Let's suppose one availability goes down, the other availability zone is available for us. Eliminating input output freeze means uh, if I have the replicated data, right, the whole output operation will not freeze. Maybe only the input operation may freeze, right, or maybe output operation may freeze, but some kind of data flow will be there. It will not go down to zero. Then minimizing latency spike during system backups, right. Now let's suppose if I am running some kind of backup, right, in that particular case what I can do is I can transfer the traffic to the replica database, and once the backup has been done on the primary database, I can switch back the traffic to my primary database. Then serving read traffic on the secondary DB instance, right, as we have already discussed, right, that I can have a main database or the primary database is only for write operation. Then there is a asynchronous backup that is being maintained between the primary database and the read only databases, and the read request will only be catered from the secondary database instance, or you can say the read replica of the primary database, right. So this is what it's saying again. So you can see the following diagram depicts the multi availability zone database instance deployment, where Amazon RDS automatically provisions and maintains a synchronous standby replica in different availability zone. The replica database does not serve read request. Okay, so here this replica database, it will not serve read request, right? I will not be able to read any kind of data from this particular. You can see no read access, right? This is my primary database, and I can do the read and write access only for from this particular primary database. It will have a copy of data, right? It will have a copy of the data so that the data replication is there, data redundancy is there. If in case of any kind of you can say a backup and power failure, I can switch the traffic to here. But in that case, I will have to not only create a standby replica, I will have to create a exact replica, right? So here you can see the following diagram depicts the multi availability zone DB cluster deployment, which has a writer database instance and two reader database instances in three separate availability zones in the same AWS region. All three database instances can serve the traffic, right? So this is just for keeping a copy. And now this system can serve the traffic. This system can manage the failover. This system can manage the backups. This system can be used when we are having a sudden spike in my user base and everything, right? So here what exactly is happening? So this is the writer database instance. So writer database instance means you can say this particular database as the primary DB. Okay. So this is my primary database, and these are the read applications, read replications or read replicas. Okay. These databases are nothing but the read replica. Again, this is second read replica. Cool. Now you can see using the primary database, the user will be able to do both write operation as well as read operation, right? Now, if there is any kind of high read intensive operations that we have to do, so I can use these read replicas just to cater for the read request. I will not be able to do this write part. This will not be allowed. This write operation will not be allowed to the read replicas. Write operation is only allowed to this writer database instance or the, you can say, primary database instance. Okay. So this is how in this particular case I can also cater a large volume of traffic. I can handle the you can say the backup thing, right? I can handle the sudden spike in the traffic. I can do the scaling part. I can do the maintenance part, right? And everything can be done in this architecture of the you can say writer database and the reader database instances. So for more information, see configuring and managing the multi-AZ zone deployment for RDS instance. Now let's understand about the access control with security groups, right? So now it's more of a you can say DevOps part of it, but let's understand about it that these minor things we should be also aware about. So a security group controls the access of a database instance by allowing access to IP address ranges or Amazon EC2 instances that you specify. You can apply a security group to one or more DB instances, right? So a security group will be something like this. Okay, so you can think of it as a gate, right? We have a gate and there will be a bodyguard that will be standing in front of the gate, right? So for it will allow the traffic of the specific IP address range or the exact EC2 instance which I specify, right? Now the user comes, right? And the user will have some kind of ID card, right? Let's suppose if we want to get into some kind of party, let's suppose, right? If we want to go into some kind of function, so I should have the proper authentication, or you can say proper authorization to get into that particular event, right? I should have the pass or everything that I should have, correct? Now this access list, right? This access list is similar to the event pass that we get, right? If my name is there in the access list, I will show, right, this bouncer and I will get into the event. Okay. If the other user comes right? If a user comes who does not have this pass, so he will be kicked out of the event, right? Similarly, if there is any system, any machine which is not listed in these access list, or which is not, I have mentioned that particular EC2 instance, or any machine, right, I have not specified in my access list, it will not allow basically to connect to my RDS instance. Okay, and in that reason, in that way, my data is safe. Okay. So the common use of a DB instance in VPC is to share data with an application server in the same VPC. The following example uses VPC security group. So let's say EC2 RDSX to define inbound traffic rules that use IP addresses of the client application as the source. Okay. The application server belongs to this security group. The second security group, named, let's suppose, RDS EC2X, specifies EC2 RDSX as the source and attaches it to the RDS DB instance. Okay. According to the security group rules, client applications cannot directly access the DB instance, but the EC2 instance can access the DB instance. Okay. Means, let's suppose I am some user here sitting outside this. Okay, I am a user, right, sitting outside this VPC, right? So I don't have the authentication and the authorization to directly connect to this particular database, right? Again, if I take an example of any application, not only Instagram, but any application, whatever we see on that particular application, it is getting fetched from some database itself, right? It's not inbuilt into that application, or it's not a static application that we use. Whatever, if we are using Google Pay, right? So my account balance, my last transactions, right? My offers, everything is getting fetched from a database. But am I able to directly access that particular database? No, right? I am only able to access that particular data, or I am able to only access the application server, right? I am only able to access the application server, and using this application server, I am able to communicate with my database, right? If I say Google Pay, right? If I say my GPay, right? That show me my last 5 transactions. Okay. So if I ask it to show the last 5 transactions I have done. Okay. So me as a user, right? Do I interact with the database? No. I do what? I ask this particular thing to my application, and the application goes or interacts with the database. The database sends back the response to this application, and once this response is sent back to my application, my last 5 transactions are visible on my application. And this is how it works. Okay. And the similar thing is being said here, right? That here, if we will use a security group named, let's suppose, EC2 RDSX, right? It will specify the inbound rule. Inbound rule means what all traffic can get into this particular public subnet, or maybe get into this particular VPC, not public subnet. Sorry. Okay. Till what IP addresses can get into this particular VPC. That particular rule is called as inbound rule. Okay. I can also specify some specific IP addresses that can only enter my VPC, right? If let's suppose I am having some kind of on-prem servers, right? Or maybe on-prem data that I have stored. Okay. Or maybe something internal for my company. Okay. I have an application that is specifically used in my organization itself, right? So what I will do is I will only allow the traffic, or I will only allow the IP addresses, or the machines that are having a pattern of IP address can only access that particular application, else no one else will be able to access that particular application over the internet. Okay. So this is how these things I can specify in my inbound rules. So the application server belongs to this particular security group, right? This application server will belong to this security group. Okay. The second security group, named RDS EC2X specifies the EC2 RDS as the source. Okay, which will be, this security group will be of this private subnet. Okay, and this security group will be will be specified so that my application server can interact with the RDS, right? So what this security group, that is RDS EC2X security group, will do what? It will cut out the internet traffic. Okay, this security group will be in such a way that it will not allow a direct traffic from the internet. This security group will only allow the traffic from the application server. Okay, and it will only respond back to the application server. Anything out of this application server will not be catered, or any request out of the application server will not be catered. And these security groups and these security rules will be specified in RDS EC2 security group. Okay. So according to the security group rule, client applications cannot directly access the DB instance, but the EC2 instance can access the DB instance, right? And that's what I was saying. So this is the EC2 instance, or you can say the application server, and the client will be not directly accessing the RDS instance. It will be accessing it via some kind of web application or application server, or maybe this EC2 instance, right? Now comes the, so for more information about security group, you can go on to this particular link. Okay. Now comes the Amazon RDS monitoring part. So monitoring is an important part of maintaining the reliability, availability, and performance of Amazon RDS and your other AWS solutions. AWS provides various monitoring tools to watch Amazon RDS, report when something is wrong, and take automatic actions when appropriate. Okay. So if anything goes down, right, if due to, for any reason, right, some kind of inappropriate thing happens onto my database, right, each and everything will be watched and monitored by the Amazon RDS monitoring, or maybe I can use other tools like CloudWatch. Okay. So it can track, it can monitor, and it can also take automatic actions if appropriate. Right. So you can track the performance health of your database instance using various automated and manual tools. Right. So using Amazon RDS DB instance status and recommendations. So view details about the current status of your instance by using the RDS console, AWS CLI, or RDS API. You can also respond to automated recommendations for database resources such as DB instances, read replicas, and DB parameter groups. So for more information, you can go on to this particular link. Then we can use Amazon CloudWatch matrices for Amazon RDS. So you can use the Amazon CloudWatch service to monitor the performance and health of a DB instance. CloudWatch performance charts are shown in the RDS console. The Amazon RDS automatically sends matrices to CloudWatch every minute of each activity of each active database. You don't get additional charges for RDS matrices in the CloudWatch. Okay. So the CloudWatch service, right, will be utilized to basically collect the matrices and show it in the RDS console itself, right? So wherever we will launch our RDS instance, there only we will get a chart and we will get the visualization of our active databases, right? And these databases will automatically send the matrices to the CloudWatch every single minute, right? So it will send information, something as, let's suppose, RAM uses, right? Disk uses, how much disk is remaining, how much disk is full, what was the input output, number of input output operations that were done, right? What was the input output latency, maybe the temperature of my server, and whatnot. Whatever matrices I want to cover, I can cover those matrices using the AWS CloudWatch matrices. Then using Amazon CloudWatch Alarm, you can watch a single Amazon RDS matrix over a specific time period. You can then perform one or more action based on the value of the matrix relative to a threshold that you have set. For more information, you can go on to this link, right? So now what this thing is saying, that using AWS CloudWatch alarms, right? What we can do is, let's suppose we have set a threshold that if my RAM usage goes above 60%, you send me an email, right? And then I will look what I have to do. I can do it like this only, right? So the matrix will be something like this. Maybe I am having this. Let me use some other color, right? So you must have seen that speedometer kind of device, kind of graph, right? So it will show you that how much RAM usage is there, right? So let's suppose 40% RAM usage I am currently doing, right? This is, let's suppose, 50% RAM usage. Now this is 60% RAM usage. And now I have set a threshold that as soon as my RAM usage goes ahead of 60%, right? So if I show you this graph, okay, if I show you guys, let's suppose Grafana dashboard, and I just go to images. So I'm talking about this graph. Okay. I'm talking about this graph, this thing. Okay. Disk utilization or maybe RAM utilization, something like this. So as soon as, okay, let me remove this. So what I was saying is, where did it go? Here it is. Okay. So as soon as it goes beyond 60%, you send me an email, right? So that I can get to know and I can act accordingly, that okay, my RAM usage is getting full on my RDS instance. Maybe I will have to launch another instance, or maybe I will have to first of all check the traffic, that am I not getting spammed by some kind of bot or something, right? If I'm getting some kind of spam from a bot, I will have to block that particular IP address and so on, right? I can get an email, or maybe I can do what, I can ask, if I'm having some kind of written some kind of infrastructure as a code kind of script, then I can ask it to launch another RDS instance, right? So again, totally depends on the use case that I am having. Okay, so this is what this monitoring and the alarming part will do. Then Amazon RDS performance insight and operating system monitoring. So performance insights access the load on your database and determine when and where to take the action. For more information, you can go on to this particular link. The RDS enhanced monitoring looks at the matrices in the real time of the operating system. For more information, you can go on to this particular link. Now integrated AWS services. So Amazon RDS is integrated with Amazon Event Bridge, Amazon CloudWatch logs, and Amazon DevOps Guru. For more information, again, you can go on to this particular link. Okay. Now the user interface of the RDBMS. Okay. So how we will be basically how our RDS instance or console will look like. So you can interact you can interact with the RDS in multiple ways, right? We have already seen by using the Amazon Management Console, which is this console that I am talking about, right? Let me zoom in a bit, this thing also. Okay. Then the command line interface. So we will have a similar kind of interface, a terminal kind of interface using AWS CLI. And we can also use Amazon RDS APIs. So if I just right click and open one of this, right, that is the API one. So I can go on to sample codes. Okay. Or maybe RDS API reference. Okay, let's select Python. Okay, and SDK for Python. Yes, let's select SDK for Python. Continue. Okay. So I will be redirected to this Boto 3 one, right? And here if I go to maybe docs or something, docs, or maybe let's go to this link. Okay. And here if I search for okay, maybe if I say get started. Okay, and code example, CloudWatch, DynamoDB. Multiple services. Okay, and here I will have to search for RDS. So I can search for RDS. Okay, so here you can see. Okay, so I will do what? Import Boto3, right? Then client will be equals to Boto3.client, and the client will be whom? It will be RDS, right? Now what are the functions that are available, right? Add role to the cluster DB instance and all these things. Okay, so these are the number of things, or the number of basically actions that you can perform, right, on top of RDS using a Python API. Okay, so we will not be focusing too much on this Python API thing, right? We will be majorly doing everything using this console itself, but I have shown you guys so that you have the knowledge and you have the information that how you can visit and how you can. And once you are good with reading the documentation, I don't think that it will be a kind of headache, or you will not be able to grasp the SDK part of it also. Okay, so let me close this, right? So using first of all the AWS console management. So the AWS console is a simple web-based interface. You can manage your DB instances from the console with no programming required. To access the RDS console, sign into your console log and open RDS console at this particular link. So what I can do, either I can just go on to my console, right? I have logged into my console currently, and what I will do is I will just go into this service, or maybe I can click on this, right? And I can click on all services, and here I can search for RDS, right? So Aurora and RDS in database, it's available, right? Or else what I can do is, if even if I don't want to search here, so I can directly do a global search on top, something as RDS, and I am getting the same thing. And now if I click it, so I will be redirected to a page something like this, right? Here I have our DB instances, DB cluster, reserve instances, snapshot, blah blah blah, right? Multiple things are there. Here we are getting an option to create a database. Here we are getting an option to restore from S3 and whatnot. Here I can view the service and health dashboard. Okay, now using this dashboard, I guess you guys are now able to relate what all things we have learned till now, right? This monitoring part, right? So here we can do the monitoring, but because currently, right, we don't have any kind of exact database that is running, but all the things. So this is a monitoring of the services of AWS services. Okay, this is the monitoring of AWS services and not our database. Okay, here when we will have a database, then we will able to basically monitor everything here only. Okay, so monitoring part you are now able to understand, right? How we will be creating these single instances, how we will be creating the DB clusters, right? How we will be creating these DB clusters, how we will be creating the snapshots, right? We have also understood about the snapshot and the replica of it, right? So now I believe these things are making sense, right? When you can see these things in the dashboard part, right? Now using the command line interface, so you can use the AWS CLI to access the Amazon RDS APIs interactively to install the Amazon AWS CLI. You can see this thing, how you can install. To begin using AWS CLI with RDS, you can go on to this particular link. Then again, Amazon RDS APIs, which we have already seen, right? Okay, so even the sample codes are available here. Okay, it's redirecting us to the same link. Okay, so using Amazon RDS APIs. So if you are a developer and you can access the Amazon RDS programmatically using APIs. So for more information, you can go on to this particular link. So for more, for application development, we recommend you to use one of the AWS SDKs. The AWS SDKs handle the low level details such as authentication, retry logics, and error handling, so that you can focus on the application logic. AWS SDKs are available for a variety of languages. For more information, you can go on to this particular link, and we have already seen these things, right? Now, one more thing that AWS people are saying is, if you are a developer, right? So it's recommended to use SDKs. Why? Because let's suppose if anything happens, right? If I am not able to authenticate a user, so what should I do? Either I will have to come here and I will have to watch the logs manually, and then I will have to know about the IP address of the of the user, or maybe the person who is trying to connect to my database, and I will have to block that particular IP. So all the things will be a manual process, right? But here, if I'm using some kind of SDKs, or if I'm using some kind of APIs, right, to do these particular things, so I can do it using the code itself. Similarly, if I'm trying to do some kind of retry logic, okay, let's suppose if the data that I am trying to insert gets failed midway due to let's say network error, okay, so I can implement the retry logic in the code itself. Else what I will have to do is I will have to log into my dashboard, right? I will have to check my database, that if the data got inserted properly or not, if the whole of the data has been ingested or not. If not, I will have to again go back to the source, and I will have to transfer the data from there to here if I'm doing it in a manual process, right? So it's recommended, right? If I'm focusing on some kind of production level thing, so it's recommended that I should use the SDKs. But currently, because like these type of questions will not be asked in the certification, right? Currently we are more focused on the certification part. So in the certification, either I can implement using UI, right? If I can implement using CLI, if I can implement using APIs, it does not matter. I should be able to implement those things, right? So for that reason, mostly we will go ahead with the UI part itself. That is, we will go ahead with the management console itself. Okay. Now, how you are charged for the Amazon RDS. So when you use the RDS, you can choose to use the on-demand database instance or the reserve DB instance. So we have already talked about it, what is on-demand database instance and what is reserved instance. For more information, you can go on to this particular billing. For AWS free tier on Amazon RDS, so you can choose Amazon free tier on Amazon RDS with the following engines and the database classes. So if you are using any of these engines, and if my DB instance class is T3 micro or T4G micro for all engines except MySQL Server Express Edition, right? I can either also go for the free tier. And in most of the cases, we will go ahead with the free tier itself, so that you guys are not charged for anything. You cannot use the following features and resources and actions in the free tier. Okay. So Amazon RDS custom engine options is not available. Reserve DB instances is not available. Deployment options other than single AZ. Okay. So we will not be able to use the multi-availability zone deployment in case of the free tier, right? And obviously it makes sense, right? If any of the provider are giving you anything for free, right? In that case, for sure they will put some kind of limitation on the users, right? Migrating snapshot we cannot do, right? There will be a limitation, right, on the query editor. And creating Aurora read replicas, again there will be a kind of limitation. Now, how much this free tier is? Okay, so if you were an AWS free tier customer before 17th July 2025, you can continue using RDS free until 12 months for the free users. During this period, you can remain eligible for the following users, that is 750 hours of each month of single availability zone DB T3 micro or DB T4G micro instances, classes running MySQL, MariaDB or PostgreSQL on RDS. Then 750 hours of each these instances running SQL Server on the RDS instance. After July 17, 2025, a new AWS free tier resources that you can create using AWS will use the new free tier offering. Okay, so it hardly matters, right? If you have created before or earlier, right, you will be able to access 750 hours of service each month. Okay, and in 1 month, how many hours are there? If I do calculator, so let's suppose even if we are having 31 days into 24, so it's 744 hours only, right? It means if we are using these 3 instances or these 2 instances with a single availability zone deployment, and we are only using MySQL or MariaDB or Postgres, right? I can use it for free, right? Because I'm having 570 hours each month, and even if it is 31 days, it is hardly 744 hours. Okay, so most of the things that we will be having will be free, at least for RDS, right? At least for RDS, you guys will not be charged anything moving forward in this particular course. Cool. So this was all about RDS, right? What exactly RDS is, right? What all things RDS has, what all functionalities, what all services RDS has, what all advantages it has. Then we did the comparison, right? Then the shared responsibility model, then RDS DB instances, its application architecture, engine, DB engines, instance classes we knew, right? Then we talked about AWS regions and availability zones. Then we talked about multi-availability zone deployment, right? We talked about access control with security groups, RDS monitoring, right? And how we can connect to our RDS. Now we will start ahead with the practical, and we will start creating our database instances. We will try to create some kind of data models. We will try to run some kind of SQL queries on top of RDS in the further videos. Cool. So this was pretty much it, guys, for this particular video. I hope you learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye-bye.